When's February? July 25th. Alright, let's do this. Oh, Jesus. I was hoping something easier. Alright, maximize subarrays after removing one conflicting pair. Integer n, which represents an array nums containing the numbers from 1 to n in order. Additionally, you're given a 2D array. Conflict pairs, where conflict pairs I indicates A and B form a conflicting pair. Remove exactly one element from conflicting pairs. Afterward, count the number of non-empty subarrays of nums which do not contain both A and B for any remaining conflicting pair. Return the maximum number of subarrays possible after removing exactly one conflicting pairs. So we want to remove one conflicting pairs, and we want to find a number of subarrays which do not contain both A and B for any remaining conflicting subarrays. So n equal to 4 we start with. So we have 1, 2, 3, 4. And 2, 3 is conflicting, 1, 4 is conflicting. So if I remove 2, 3, then we have 1, 4 left. So I just need to find the number of non-empty subarray that does not contain 1, 4. So size of 1, definitely, so we have 4. Size of 1. Size of 2, because 1, 4 is here, so we have 3. Size of 3, and that's it. So this gives us 9, right? So if we remove 1, 4, then we have 2, 3. Again, we have 4. But then we don't have 3, we only have 2. And we don't have this, we only have this, so we only have 1. And we don't have this. So this will give us 7. Therefore, the answer is 9. Let's see the constraints. 2 times n. Alright, so we want to remove one of them. What if we don't remove anyone? That's probably, I don't know. Number of subarrays that do not contain both A and B. So I have the total number of subarrays that I can do. That I think is 2 to the n. That's the number of 2 to the n minus 1, because we cannot do empty. So it's 2 to the n minus 1, right? No, I don't think so. I think subarray is n plus n minus 1 plus plus 1. Yeah, that's the whole, which is n times n plus 1 divided by 2. This is the total number. So maybe what we need to find is the number of subarrays that containing all of these, right? Number of subarrays. So, in other words, what we need to find is the number of subarrays that can, the pair, right? The pair that has the fewest number of subarrays that containing it. So in this case, 1, 4, we only have one subarray, right? So that's the one. So the answer is 10 minus 1. In this one, the total number is 5 times 6 divided by 2, which is 15. And we need to find how many contain 1, 2, gazillion, right? How many contain 2, 5? Ooh, 2, 5, because there's a 1, 2, 3, 4, 5. Contain 2, 5 is 2. We have 2. 3, 5, we got more, right? We actually have 3, because we have, 1, 2, 3. So the answer is 13, but it's not 13. Okay. No, hold. We need to remove the ones that have the most, not, we remove the one that have the most. I scratch this. We should remove the one that has the most. So the one that contains the most is the thing that's closer together. So yeah, we remove 1, 2. Is it 1, 2? The 1, 2, 3, 4, 5, right? So I have 1, 2, 3, and 4. 4 of them contains 1, 2. Huh. So if I remove this, wait, hold on. I know the total number, right? And I need to find how many subarrays are contained by the remaining, right? How many subarrays are contained by the remaining. And yeah. So if you have something that's close together, you should definitely. Can we say we always remove the one that's the closest together? Wait, hold a second. So yeah, how many we cannot do, right? So 1, 2 will have 1, 2 by itself. We have 4 that we cannot include. So if we include 1, 2, we cannot do 4. If we include 2, 5, we cannot do 3. We cannot do 2. If we include 3, 5, we cannot do 2. But they overlap, right? They overlap. So the best we should do is, if they have duplicates, like, why do you remove 1, 2? Because, like I said, you include 1, 2, you have a lot more that you need to remove. Actually, it's not a lot more because 2, 5 will be included in one of them. Yeah, we just want to see how many need to be removed, right? How many needs to be removed, and we want to remove as few as we can. So I don't know. 1, 2. I don't know. I'm just trying stuff. 2, 5, 3, and 5. So everything including 1, 2, everything including 2, 5. I can calculate how many are including this. I can calculate it, which is just because I have a range of AB, right? So that's 1, and then whatever to the right, actually including this, and then whatever here. So like 2, 5, if it's 2, 5, I have 1 on this side, I have 2 on this side, so the total is 2. 3, 5 I have, so this is 3 on this side, right? A 1 on this side, so I have 3. 1, 2 will have 1 on this side and 4 on the other side, right? 4 on the other side, so this will give you 4. So this one, if I include this, I'll miss 4. If I include this, I'll miss 2. If I include this, I'll miss 3. Now the question is, once them combined, how many are we going to miss, right? So in this case, when they're combined, I'll take 3, 5, so we'll miss 3. That's why the answer is 12. Which means if I remove 1, right, we have these ranges. Okay, we have these ranges. So if they overlap, what's going to happen if they overlap? Let's say we have, 1, 3, okay, and 2, 4. So they have overlap. What's going to happen when they have overlap? Well, 1, 3 will be like everything. So there will be something that can exist, right? So it'll be 1, like 1, 2, 3, 1, 3. Maybe 4 is not the best example. Let's get a little bit bigger. Let's say 6. Okay, how about 6? Get a little bit wider. So we got 6. Okay. So 1, 2, 3. We have 4. We have 5, and then we have 6. So 1, 3, like 1 to 4 is 1. This one doesn't count. 1 to 5, right? And then 1 to 6. Now 1 to 6, the first one and this one count. So I just want to know how many subarrays will be excluded if we have 1, 3, and 2, 6. So let's say we end up at 7. So 1, 3 will give me 1 times 5. This will give me 5, right? Just 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. That's 5. And 2, 6 will give me actually 2 on this side, and then 2 on this side. So this gives me 4. So we'll be, actually, we can write it out, right? We have 1, 3, 1, 4, 1, 5, 1, 6, and 1, 7. This will be, I can pick 1, 6, 2, 6, and 1, 7, and 2, 7, right? So there are overlaps. The overlaps are 1, 6, 1, 7, 1, 6, and then 1, 7. So these are overlaps. How do we determine the overlap? They are this and then this, right? Okay, and then go beyond. So can we say the overlap will be, we take the extreme, so that's 1, 6 basically, right? If we have 1, 6, then everything that 1, 6 can every subarray that contain 1, 6 will be contained by both 1, 3 and 2, 6. And that's the overlap. And we need to remove those, right? Remove those. That sounds reasonable. That does sound reasonable. Because anything that doesn't including 6, they're unique, right? Everything that's, they're just unique. Okay, so what if there are no overlap? 1, 3, 4, 6. Okay, 1, 2, 4, 6. There's no overlap. I think that's the same, right? So like in this case, I have 1, 2. So I have 1, 2, 1, 3, 1, 4, 1, 5. Like none of these are overlapping. The thing that starts over like 1, 6. 1, 6 is the first thing that overlap. So I have 1, 6, 1, 7, right? So from this perspective, I have, because I have to have 4, 6, so it'll be 1, so like 4, 6, 3, 6, 2, 6, right? They don't overlap, but 1, 6 is the one that overlaps, right? And then again, like 4, 7 doesn't matter, 3, 7 doesn't matter, 2, 7 doesn't matter, but 1, 7 matters. So it's still 1 and 6. Okay, I want another scenario. Let's call it 3 to 4 and 7 to 8. So we have 5, 6 in between. Let's call it 9 here. Let's call it 1 and 2. So if I have this and I say how many subarrays that include these two. So for, I think it's 3 to 8, right? Anything that contains 3 to 8 will contain them, right? It's just like if you don't contain 3 to 8, like you just like say 3 to 5, yeah, like 3, 5 doesn't matter, 3, 6 doesn't matter, 3, 7 doesn't matter, but it has to be 3, 8. And then the same thing like 2, 2, 2, 5, 2, 6, 2, 7 doesn't matter, 2, 8 matters. So this, it doesn't matter if they overlap or not overlap. The duplicated subarray can be found by simply getting the maximum, right? Okay, this sounds reasonable. Next, what if I have 3? Right? What if I have 1, 2, and 3? So I say these two, the overlap is produced by this, right? So like everything that contains this will contain both, so we don't count them twice. And then now we have essentially the total number of subarrays that contain these two, right? That contain these two, which is bounded by this. So now I say, okay, let me introduce this. So it will be total number of here, right? So you consider this as a unit. Can I consider this as a unit? Can I? As a unit? And what I'm trying to do is to see, because subarray containing this, right? Subarray containing this, it might contain these as well. So how do I deal with that? I might need some example. I need an example to kick things started. So we can just start with 1, 2. I'll skip 3, 4, 5. I'll skip 6 and 7, 8, and I'll end at 9. Alright. So now 1, 2, right? We have 1, 2. We have 1, 3, 1, 4, 1, 5, all the way to 1, 9. For this, I have 1, 5, right? 1, 5, 2, 5, 3, 5, 4, 5. And then 1, 6, 2, 6, 3, 6, 4, 6, and all the way. So all the 1s are gone. Basically the 1, 5, right? 1, 5 is gone. Well, it makes sense. All the 1, 5s are gone. So the 1, 5, so basically this is gone because the 1, 5, 1, 6 is gone. 1, 7 all the way to 1, 9 is gone. So what we left with is 1, 2, 1, 3, 1, 4, 1, 2, 1, 3, 1, 4, Right, 1, 2, 1, 3, 1, 4, and then I mean 1, 5. It's not gone. It's just we have to delete it here, right? We have to delete it here. So 1, 2, 1, 3, 1, 4, 1, 5, all the way to 1, 9. And here I just don't do any of the ones. 2, 2, 2, 5, 3, 5, 4, 5, 2, 6, 3. And then 2, 7, 3, 7, 4, 7. And 2, 8, 3, 8, 4, 8. And then 2, 9, 3, 9, and then 4, 9. Okay, so that's, yeah, these are gone, so I can just delete those. So this can be computed. I have 1, 2, I have 9, I have not 9 here, it's 8. Right, I have 1, 2, 3, 4, 5. So 5 times 3 plus 8 is 23, which can be computed by, this is, I just double check the math to see if it's correct. So this is 1 times 8, right? Plus this will be 4 times 5, right? Minus 1 times, I'm using 5, so it's going to be 5. So this is 8 plus 20 minus 5. That is 23. Yes. Okay, so this makes sense. So now we added another one, right? We added 7 and 8. So for 7 and 8, what we have, we start from 1, right? We have 1 to 8, 1 to 9, 2 to 8, 2 to 9, 3 to 8, 3 to 9, 4, 8, 4, 9, 5, 8, 5, 9, 6, 8, 6, 9, 7, 8, 7, 9. That's it. Right? So this, what we have is 7 times 2, we have 14. Right? We have 14 of them. Now, this needs to be deleted because 1 already handled. Right? 1 already handled. So 1, 8, 1, 9, 2, 8 gets handled here already. See, this is 2, 8 is getting handled already. 2, 8. 2, 8 gets handled. 2, 9 gets handled. 3, 8 gets handled. 3, 8. 3, 9 gets handled. 4, 8, 4, 9 all get handled. But that's it. We don't have 5. Right? We don't have 5. What does this mean? Right? What does this mean? Well, this simply means that it has to be from 5. Right? Because we do this, anything starting from the middle, starting from here, all the way to 4, will all be handled. So the only thing that cannot be handled is starting from 5. Right? Starting from 5, the things do not get handled. So in this case, it'll be 7 minus 5 plus 1, so it'll be 3. Right? We started from this 3 times 2, should be 6. So that changed the perspective. Alright, it changes perspective. So essentially, what we're saying is, if I ground the first, so total will be, I delete this. So total should be 29. Right, it'll be 29 of them that gets covered by everybody. So in this case, this gives us 1 times 8. This gives me 8. So from this, I can now go here, but I can start on 2. Right? So that will be 4. That will be 3 times 5. That will be 15. And this will be 3 times 2. That will be 6. Okay. Oh, if none overlapping, we can do it. We can count how many, right? How many? What if we overlap? What if we overlap? This is kind of a different. So if we overlap, right? If we overlap, let's say, 1 to 5, and then we have 3 to 6. So we go 1 to 5, everybody, right? So yeah, 5. Let me move 5 a little bit more to the center. So 5 should be here, right? So I got 1 5. Right? I got 1 5 1 6 all the way to 1 9. Yeah, let's also say go to 9. Now for here, again, I cannot start from this, right? Because it's already been covered. So the original will be starting from this, but here I cannot start from this. I can start from 3. So the smaller between these two, because I can start from 3, right? 3, 3 6, 3 7, 3 8, 3 9. Anything smaller than 3, I can do as well, because I can do 2. I can do 2. So as long as not this one, it's fine. Wait, hold a second. Oh, it's just an accident. It's not considering this, it's considering this. Anything, like if it's, let's say, even if I don't have overlap, let's say 7 to 9, right? So I do 1 5, everything starts from 1 or smaller. So for this, my starting point is just not 1 but 2. I start from 2, then everything don't get overlap, right? Nothing gets overlap, because this has to start from something 1 or smaller, right? So I just make sure the starting point don't overlap, then nothing will overlap. That's not a bad idea. So for 3, I just start from 2, right? So instead of 3, so I actually have 2 on the left hand side. So it's 2 and 3, so 2. And this will be 4. So this will be 8. And this will be 1 times 5. So this will be 5. So total will be 13. Right, total will be 13. Let's see if it is 13 from another perspective. So another perspective will be 5 plus, so this will be actually 3 times 4 minus 4. So it's 5 plus 12 minus 4. Yep, that's 13. Alright, so it's actually not that hard. We just get we sorted everyone, and we know starting from where. We're just starting from this one more, right? Which means this is to count the number that need to be eliminated, right? The number, so we know the total number. We sort it, then we just need to know after we remove one, what is the result? What is the total number? So let's use this as an example. Okay, so we have 1 2, sorted 2 5, sorted 3 5. So without anybody gets removed, this will give me, because I took 5, so this will give me 5 5 5 5 5 5 5. 5 minus 2 plus 1. What's that? That's 4, right? So this will give me 4, and this again. So I'll check this, and then we have this will be 1 times 1. This will give me 1. Right? And this again, that's 1 times 1, so give me 1. So in total will be 6 gets, so we have 15 in total, right? So this will give me 6 in total. So now I start remove. If I remove this, how will the rest change? Now, when I remove this, only thing changes the 1 right next to it. Everybody else is the same, right? Everybody else is the same. So essentially, what's going to happen is I count the total. So this will give me 6, right? That's a total. So if I remove conflict 0, what's going to happen is 6 will minus whatever the conflict has, but I need to plus. Actually, we need to remove both the conflict and the one after the conflict. So I need to remove both and add the new one. So we remove the conflict and one after conflict, and plus what will happen. So after remove the conflict, I have this will go to the front, so that's actually 2 times 1, right? So this will give me 2. So this will total, the remove is 6 minus 4 is 2. 2 minus 1 is 1. 1 plus 2, it will become 3. So I remove this, I only have 3 to remove. Okay, now let's say if we remove conflict 1, if I remove this, so that's going to be 6 minus, I'll remove this, I need to remove this, and then I plus, after I remove this, what's going to be this? So I do this minus 1, right? I do this minus this, and plus 2 times 1. So this will give, my goodness. I have no idea what to do, man. The cat is absolutely destroying me notebook. Oh shit. Alright, where am I? Yeah, so this is gonna be 4 plus 2. This is gonna be 6. Right? 4 plus 2 is gonna be 6. And if I remove the last one, it's gonna be that if I remove conflict 2, it's gonna be 6 minus, again, 1. But I don't have another one. It doesn't even matter. We just minus the last one because everybody else will be the same. Right? It will be the same. So this will be 5. So minus this will have 5. Why they're different? 5 gets impacted. But I remove the middle, will be 6 gets impacted. Five and 6. Okay. I get that. How about I remove this? Oh, that's just 2, 5. Yeah. Yeah, that's 5. Alright. That seems reasonable. Let's code it up. Taxi. Yep, that's tax. Oh. Alright, let's code it up. I'm pretty confident that this is correct, but still need to code it up. Alright, how would you gonna explain it? Let's explain this. 34A0. We know the total number of subarrays, okay, non-empty subarrays is n times n plus 1 divided by 2, right? Thus, all we need to find is the number of subarrays that will be excluded, right? Excluded after one conflicting pair is removed, right? Yeah, after after one of them is removed. We can sort the conflicting pairs by their starting point. I wonder if the end point need to be sorted as well. If I sort them by the starting point, what if the end point, actually I don't think we ever discussed this. What if I have, let's say, 2, 5, and then 2, 7? What's going to happen? Well, we started from 2. Oh, I think the end point doesn't really matter. Yeah, it doesn't really matter. I don't think it matters. So we just sort by their starting point, right? Say we have 2 such pairs, okay? A1, B1, A2, B2. The number of subarrays excluded due to A1, A2, B2 in with n, right? Due to this is A1 times n plus 1 minus B1. Okay, and the number of subarrays excluded due to A2, B2, hold on, where A1 smaller equal to A2, right? But not counted already by A1, B1 is A2 minus A1. Yes, A2 minus is A1 plus 1, right? A2 minus A1 plus 1, then plus 1 is A2 minus A1 times n plus 1 minus B1. Right? So follow this formula. We can find the total number of excluded subarrays without removing any pair. Then we remove one pair, and then we remove one pair. The number of excluded subarrays, right, will only be affected by the removed pair and its next neighbor, right? Then its next neighbor. We will remove them both, right? And then recalculate the excluded subarray from the next neighbor, since it has a different previous neighbor. Right? A different previous neighbor. We go through all the pairs for removal and find the setting with the minimum, the lowest number of excluded subarrays. That, I think, is the solution. Okay, so now let's code it up. First things first, I say total is n times n plus 1 divided by 2. This one's fine. And then we say sort conflicting pairs dot begin, conflicting pairs dot end. Hold a second, I need to respond to a message. All right. Next, we need need to find the total pair, so this should be the total subarrays. Okay, total excluded. How do we do it? We say for int I equal to 0, I smaller than, actually we can do 1 if you want to. No, I don't want to. Really, you don't want to? Then we'll make it faster. Okay, so the first one, right? The first conflicting pairs. So this will be conflicting pairs 0, 0. That's the first one. Times n minus conflicting pairs 0, 1. So, right? And then the second say from 1 smaller than conflicting pairs dot size and I plus plus. Now, what we're gonna do is a total. Ooh boy, this should be long, long. Oh boy, long, long this. Oh shoot. Okay, so total excluded. Now I'm a little bit worried. Now I'm a little bit worried. So here is conflicting pairs I 0 minus conflicting pairs I minus 1 0. That's that. And times n minus conflicting pairs I 1. Oh, where's plus 1? Okay, plus 1. So, okay, so this finding the total number of excluded. Now we're going to go one by one. We say, oh, I'll remove this, what's going to happen? Or remove this, what's going to happen? So if I remove the first one, it's, I remove this, and then I remove this, and I reconstruct this. So long, long, minimum excluded, right? Minimum excluded. So essentially we'll recompute. So we remove the first one. So I remove this, this, and plus this. Essentially we say long, long, conflicting pairs 1, 0 times n minus conflicting pairs 1, 1 plus 1, right? 1, 1 plus 1. So this is remove the first pair. And then for int I, y smaller than conflicting pairs dot size I plus plus, so I can remove every single one, right? I can remove every single one. So what do? We say long, long current excluded, right? Current excluded. Technically we can do long, long current excluded, so I don't have to reinitialize. So actually current excluded. So current excluded will be total excluded minus, oh, I actually need every single body. I need everyone. I need everyone. Holy crap. What's the size? The size should be conflicting pair dot size. Right? That's the size. And then I have Lord, excluded 0 shall equal to total excluded. And then Mamma mia. Excluded I shall equal to this. And then total excluded plus equal to Alright, so this is this. And I get mean excluded, current excluded. So total excluded minus excluded I, this is the current one. So I'm excluding this one, right? And then we have the next one. If I is smaller than conflicting pair dot size minus 1, then current excluded, well, minus equal to excluded. Here we go. I just do that. So I don't need to do this. I don't need to do this. I don't need to do this. So minus this minus excluded I plus 1 plus a new thing. It feels like I need to write a function to do this, because it's going to make things a lot easier. Like seriously, a lot easier. But I'm a little bit lazy. Okay, I'm a little bit lazy. So what I'm going to do is simply we're going to go long something times something. Okay, so this is conflicting pairs I plus 1 0 minus conflicting pairs I minus 1 0. Right, because we removed the 1 in the middle, so we reset this, and times n minus conflicting pairs I plus 1 1 plus 1. Okay, so that's current excluded. Current total minus this plus this. Okay, that's the current excluded. And I say minimum of minimum excluded and current excluded. Current excluded. Okay. It's discarded. Excluded. Alright. So at the end I need to do it one more time, because I should say mean excluded and will be total excluded minus the last one, excluded conflicting pairs. Oh Lord, let's do conflicting pairs dot size. So this will be m. This will be m. This will be m. And this will be m minus 1. Because this is the last one. You just remove it and then everything is fine. Right? Okay. So this is main excluded. Then we can just return total. Not total. Then we can say total subarrays. Oh Lord, this is not right. I have to go long. Okay, so we'll return total subarrays minus minimum excluded. All right, let's give this a whirl, and hopefully it works. It was not the case. Well, we debug it. I think I still have some Ghana, so let's debug it. Oh, we have a vector of a vector, now we have an n. So n is 5. This is gonna be a vector of a vector. actually we need to clan. It's 25 today. All right, let's debug this baby. Let's see, we ran this one already, so we should know the exact value for every output. We have conflicting pairs. Actually don't need this. I know what the conflicting pairs are, so I can do that. I need the excluded. Wait, hold on, what is excluded? Excluded is an array. All right, fine, it's fine, it's fine. So total subarrays. Total subarray 15, that is correct. Okay, total subarray 15, that is correct. So we're gonna go, I remember it's F2? Yeah. So total excluded, which is the first, where is our, oh Lord, what the hell is this? This will be 4. Total excluded 4. Okay, excluded 0 is 4. That's fine. And then for this excluded, this shall be 1. Yes. Total excluded is 5. Next one should be 1 as well. Yes. And 6. Yep. Total excluded is 6. Good. So minimum excluded is we remove the first pair, which is equivalent to, oh, I see what happened. I see what happened. You remove the first, right? When you remove the first, you have to put the second in. Oh, actually, I think we don't have to. I think we can start from here, right? We remove the first, we remove the second, my bad. This is not necessary. All I need here is going to be, I need a min, so it'll be long max. Okay, so let's try again. Try again. Oh, what the hell? Overflow? What overflow? Well, I can do total subarray, just in case that's the reason. Huh. Oh, I do have a -1. Oh, so. Alright, no, that's undo. Oh, I mean, that's fine. So essentially, what we are saying is this has to be total excluded minus, yes, minus excluded 0 minus excluded 1 plus this. Right? We minus the same thing, minus this, and plus this. But when I plus this, it's this thing I cannot handle. So, all right, let's try this one. Third time's a charm. So let's see if we got a charm out of this. Did we get a charm out of this? Come on. All right, let's see if we get a charm out of this. Give me some charm. Give me some charm. We don't. Oh, we fail on the set. Wait, what? Oh, shoot. I don't have. Oh. Well, I just removed that one, right? So that's kind of, we can say, oh, Jesus. Yeah, let's do this one first. Okay, edge case. If m is equal to 1, we will return total subarray. That's some edge case. All right, let's try. Let's try. Let's try. Oh, that is not right. What? What? Yo. Yeah, they never said that these two are, they never say these two are sorted. Jesus, come on. Oh boy. Okay, that's fine, that's fine. So we will not sort them, but we have to go through and, oh shit, jeez, for auto P of conflicting pairs. If P0 is larger than P1, right, then I think it's a swap. No? There's no swap? Huh. P1 equal to P0 and P0 equal to P1. No, equal to temp. So we have to do a little swap. All right. Let's see. This one error uses this test case. So try it again. All right. Let's see if this one works. I mean, we did change the original array, which is not the best. All right. Now we don't know why. I think we fixed everything, but still this is not right. All right. There we tried, and it didn't work. Maybe we can debug this. I do think we probably can debug this. I just wonder why. So basically we are counting less than we should. All right, anyway, go to tutorial, we'll copy and paste, and then we will go back again. This is a copy and paste. Copy and paste. Already spanned. Already spent an hour on this. Let's debug some other time. All right, let me just submit this, and then we return to the previous one, right? Oh, I should put the use case. Okay, so let's now do the last submitted code. Actually, not last submitted code. We should go back to this one. Right, well, we do this. There we go, nice. Good, and then we run it, and it's wrong, and we'll figure out. That'll be it. I'll see you guys tomorrow.